Hello, let's continue our Sudoku adventure with Headless by Palfly Kampling. So, it's just Renbands today, standard Renbands. So I'll go over the rules. We have standard 6x6 Sudoku rules, which means in every row, every column, and every 2x3 box, we are placing the digits 1 to 6 exactly once each. We also have these purple lines in the grid. These are Renband lines. So let's take this line as an example. Sometimes they have little lips like this. This is just cosmetic, right? Just look at what cells they occupy. That's the important bit. But the cells on a Renband line, first of all, they don't repeat. It's a non-repeating set of consecutive digits. So this line is 4 long. So we need to think of 4 consecutive digits, maybe 1, 2, 3, 4, 2, 3, 4, 5, or 3, 4, 5, 6. In fact, that's all of our options. Pick one of those, and the digits on it need to be one of those consecutive sets. So, or in other words, whatever digits we put on here need to be a non-repeating consecutive set. But any order is fine. So we could do 3, 1, 2, 4. This has 1, 2, 3, 4 on it. That is a non-repeating consecutive set of digits, so we're good. We could also do 2, 5, 3, 4. And this has 2, 3, 4, 5 on it. That would be fine. What we can't do is repeat a digit, so this can't be a 4 in this case. 2, 3, 4 is consecutive, but we're repeating the 4, and that's no good. And what we can't do is 2, 3, 4, 6, because the 6 is kind of not part of our consecutive set. It's not consecutive anymore. And that's it. Those are the rules. There's a link in the description if you'd like to try the puzzle yourself, and I'm going to get started right now. First thing I noticed is this is a 6-cell Renband, which means it has all 6 digits on it, which means it needs a 2 and a 4, and this 2, 4 says not here. So actually there's a 2 and a 4 somewhere up here. Against my better judgment, I'm going to corner mark the line with 2, 4. This line is 1, 2, 3, 4, 5 long. So a 5 long Renband, if you think about it, it's either 1 through 5 or 2 through 6, meaning it always has 2, 3, 4 on it, or 2, 3, 4, 5 on it. It can only be, we can only omit the 1 or the 6. We can only omit an extreme digit. So this has every digit except 1 and 6. Now, does that help? Not at the moment. Let's see. What else can we say? These are 4 long, so these definitely have a 3 and a 4 on them. It's either 1, 2, 3, 4, 2, 3, 4, 5, or 3, 4, 5, 6. And so the 3 and the 4 are always present. Same here. So if this needs a 4, this 4 says not here and not here. And it does need a 4 on it. So the 4 ends up there. So this can't be a 4. Meaning the 4 is one of these 2 cells in this box now, which is nice. This does need a 3 on it somewhere. This needs a 4 on it now. And that's going to be here or here. I don't know which one. Okay. What else can we do? These 2 4s look up, putting a 4 over here. But since the 4 is in one of these 2, it's not here. So the 4 is placed there. So we know this needs a 4 because it needs every digit except maybe it can be missing a 1 or a 6. It's missing a 1 or a 6 only. So if there's a 4 on here, the only place it can be is right there. So that's our 4. That reduces 2 to one of these on this line. It's hard to scan this puzzle, to be honest, but we're getting there. We do need a 4 in one of these 2 cells. There's a 2 down here. Might as well mark that. Okay. Is there more with the fact that this has every digit and can't repeat? Is there more to do with that? So far, we've only placed 2s and 4s. So this Renband might be interesting. It's 3 long, so it can be 1, 2, 3, 2, 3, 4, 3, 4, 5, or 4, 5, 6. But it doesn't have a 4 on it. This is length 3 without a 4, so it can't involve a 4, so it can only be 1, 2, 3. All the other ones use a 4. 2, 3, 4, 3, 4, 5, and 4, 5, 6 need a 4. So this is a 1, 2, 3 triple. We know this can't be a 2 because the 2 is on one of these in the row. And we know this can't be 2 because there's a 2 in the row already. And so if this needs a 2, it's going to end up here, which removes this and this as a 2. That places the 2 for this Renband. Okay, that sounds like progress. Now, something to keep in mind is this is a 1-3 pair. One of these will be 1, one of these will be 3, because we can't repeat them. And so anything that sees that 1-3 pair cannot be 1-3. So I guess another way to put that is actually, let's do a little coloring here to demonstrate. I'm going to use green for, actually, no, let's use orange for this 1-3 and blue for this 1-3. I didn't want to use, I have color combinations in my head, like blue and orange go together, green and purple go together. And so I don't like using purple if I can avoid it on a purple line. Anyway, so this is the orange 1-3 and this is the blue 1-3. We don't know which is which, but we know they're different. So where does the orange 1-3 go in this box? And the answer is it can only go here. This is the only other cell in the box that can be the orange 1-3. And so that does mean, yes, this has every digit. So it's going to need a blue 1-3, which doesn't go here. So the blue 1-3 is one of these two. We don't know which. I use that little white slash to sort of denote that. Okay, so this can only omit the one. Yeah, so this needs a 3 on it, right? This line here needs a 3 on it. Kind of hard to see because they overlap, but the 1-3 pair says the 3 doesn't go here, right? So if the 3 is not here or here, and the 3, this is a 4 already, the 3 goes here. Now we do need a 5 on this line as well. So there's a 5 in one of these two. All right. We do have these two oranges looking down, which means that orange is also on this line, which would make it interesting if it was a 1. In fact, it cannot be a 1. Ooh, that means orange is not 1. So look what happens if orange is 1, right? We end up with a 1 on this line somewhere. Let's just pretend it's here. So if orange is 1 and it ends up here, that's a 1. So that means this is a 2, 3, a 1, 2, 3, 4. But this cell cannot be 2, and it also can't be 3 because this is the blue 3, right? I don't know if that made sense. I could go over it again, but basically what I saw is that we can't put a blue 1-3 on here. And if we put an orange 1-3 on here, we are going to need a blue 1-3. And so, because actually, does this line need a 2? I guess that's the first question. It doesn't need a 2. We could do 3, 4, 5, 6. But once we put a 1 on it, it does need a 2. So that ends up to 2. It's the only place that can be a 2 on it. And then now we need a 3 with it, and we couldn't do the blue 3. So anyway, I hope one of those ways of explaining it helps. But anyway, that does mean that orange is 3 and blue is 1. And that does mean there's a 3 on here. So this is 5, 6 only because it can't be 3. So what does that mean for us? We have something really interesting going on here. There's probably an easy way to see this, but this is interesting. So I was thinking about whether this can be not a 2, right? Can we omit the 2 from this Renban? And the answer is maybe, right? Only if it's 3, 4, 5, 6. Well, if this is 3, 4, 5, 6, since one of these is the 3, we'd have 1, 5, 6 here and the other 5, 6 here, and that would break this cell. Right? If this was 3, 5, 6 and this was 5, 6, we'd have one of the 5, 6s here and another 5, 6 here, and now this wouldn't have any value. So this must use the 2. So we place the 2. This is 3, 5, 6, but now that there's a 2 on it, there can't be a 6 on it. This is 3, 5, and this is the 6. So this ends up 2, 3, 4, 5. Very nice. This is 1 and 5. This is 2 and 6, and this is placed as a 1, and this is a pair, 5 and 6. All right. Okay, so this is going to be a 2, 3, 4, 5, 6 line. It omits the 1. In fact, this is 5 or 6 here as well. We are going to need a 1 on this Renban. In fact, so this Renban needs a 1, and it's not here, right? So the 1 ends up here, along with whatever blue was. I don't remember what blue was. I think blue was the 1, actually. And so now that we know blue is 1, 1 is here, which means this isn't 1. So that's a 5 and a 1. And so this is 1, 6 pair. The 1, 6 pair means the 5 has to go here on this Renban, which makes that the 6. That's a 6. Very nice. Okay, so this is 1, 5. Okay, these are 3, 4, 5. That's not 3, that's not 4. So we probably have to think about this line soon. So how shall we think about it? It must have a 3 on it, right? We talked about that earlier because it's 1, 2, 3, 4, 2, 3, 4, 5, 3, 4, 5, 6. So it has a 3 and a 4 on it. And so the 4 is actually placed on it. Pretty sure that has to be 4. If we omit the 4, we can only be 1, 2, 3. Yeah, okay. So that's the 4. And we need a 3 on it. This can't be the 3. So the 3 is in one of these two on this line, which actually makes this the 5 and the 3, and the 1 and the 5. 6 and 1. All right, now we just have pairs. Should resolve itself. This is 5, 6. This is 2, 3. So if this is 2, 3, 4, we're not putting a 6 on it. We got to put the 5 on it. That resolves all of these. And our final digits are 1 and 4, like that, and we're done. That was a neat puzzle, Palfly. Thank you. A really nice use of Renban there. The overlapping Renbans was interesting, and I like that you were able to draw them clearly. So we saw how they overlapped. And it's a neat picture. We've got a cube, and then whatever these are. So yeah, I really enjoyed that. There was some really intricate logic there. Thinking about this line especially was interesting, and how we resolved that it had to have a 2 on it. There was more to it as well. So yeah, cool. I enjoyed that. Hope you did too. If you did, then why not leave a like, subscribe, and a kind comment below.